Ladies and gentlemen, one of the key assumptions in regression diagnostics testing is multicollinearity. And I want you to please understand this well. It's very important. I will not lie to you. If it is a big problem in your work, it can cause problems. What is multicollinearity? Multicollinearity exists when two independent variables are so highly correlated that it becomes difficult to disentangle the partial effect of one of the independent variable from the other on the dependent variable. It becomes hard to disentangle or separate those partial effects because the two variables are close. And so when two variables generate the same correlation coefficient, we say there is a perfect collinearity. And with such a perfect collinearity, the model parameters will become indeterminate. The estimates will not be reliable. The standard errors becomes infinitely large. That's when there's perfect collinearity. But most of the time, you will not have perfect collinearity. Most of the time, you will have high multicollinearity. Now, a perfect collinearity is when you define a male as 1 minus female. That's a perfect collinearity. So in your data, you will have male, and then in your data, you also have female. Now, why are you doing that? Because the two variables, when you check their correlation, they will show what? Perfect. Because one will be 1 minus the other. So it's very important. But multicollinear variables, for them, they are two independent variables that are highly correlated. So for them, it's not perfect, but it's high. And you check that by their correlation coefficient. It can be a case if it is so high. Now, why is it a case? Because sometimes the OLS becomes unbiased with large variances. And we can commit type 1 error and have insignificant. I'm giving you reasons. So when you're actually having someone's paper, you're criticizing, and the person, is indicating a lot of multicollinear variables that were not correct. There's a possibility of these mistakes. Insignificant coefficient. Okay, you will have a big R square, but your coefficients are not significant. That's serious. Your R square is indicating that there's a strong relationship between the independent variables and the dependent variables. And yet, you go and check strong relationship and yet nothing, no significant results. How can it be strong and yet not significant? It's like someone who is so big, everybody's scared of the person, but when you touch the person, he's crying. What is that? And so that is what you want to really, really check. So that's why we check for multicollinearity. Now, how do you check that? You use something we call the variance inflation factor. The variance inflation factor is a powerful, powerful phenomenon that is used to check for the multicollinearity. Variance inflation factor. Okay, it's a wonderful, wonderful thing. It measures how much the variance of your coefficient is inflated by multicollinearity. And how do you calculate it? It is 1 over the 1 minus the R squared. This is a formula. Sometimes it's nice to bring some of these formulae into journal papers or theses to indicate that you are learning. Now, the rule is that most of the time, according to Rudridge book, when the variance inflation factor is greater than 10%, it indicates high collinearity. So it must be bigger than 10% before you get scared. Well, not even that, you shouldn't be too scared. But that's when you get concerned, you become concerned. But if it is less than 10%, you can't be concerned. So that means that we need to calculate this variance inflation factor for each independent variable before we become concerned about it. How do you do that? Well, let me remind you something you already know. Okay. These were the correlation matrix. That's the correlation matrix that we had. And in this correlation matrix, we were able to identify the last time, if you check again the other videos, those independent variables that are highly correlated with the dependent variables. Now, let me remind you, let's assume that we want 3 pairs of variables that are highly correlated. Remember, when you want 3 pairs of variables that are highly correlated, Where is that? Okay. When you want 3 pairs of variables that are highly correlated, you do not include this section, the dependent variable section. It's not part of it. That's not part, because the dependent variable is not an independent variable. The focus is to deal with independent variables. So it starts from section here. Okay. So anything that is from this section, okay, going down here, okay, and then this section, okay, going down here, all the things in there, here, okay, excluding, of course, the 1, 1, 1. Okay, you check those that have high coefficient, whether it's positive or negative, you must have high coefficient. Okay, and then it will mean that there appear to be some high correlation there. So you note them down with your eye. So if you look at this, the first variable that is so high appears to be negative 0.74. No, positive 0.76. Okay, so that is the first variable coefficient. So this means that there seems to be a high correlation between OTR and then price. That's what it means. The next one could be this negative, is that negative 0.74. Okay, that could be the next one. And then the third one will be what? The third one will be negative 0.73. So you note them down. So this one means that there appear to be a high correlation between complement price and price, and then between religion, Muslim, and then income. Of course, you will understand the principle behind what you are doing, the theory, the concept, and all of that. So that will help you to know that, oh, yeah, that might be true. Okay. But whatever it is, these variables, complement price, occupation, trading, religion, Muslim, and then income, these variables may exhibit somewhat collinearity. It's just may. You have to check with the variance inflation factor. So how do we do that? How do we get a variance inflation factor? This is critical. This is critical. Okay. Now you get this variance inflation factor. First, if you have not, in this content we have, if you have not activated a library card data, a package, you do that. Okay. Then you now use this command. So I'm going to do that in our data set. So it means that whatever data set you have to verify this. So you do car VIF gene multi, it will check for the multicollinearity. Let's run that. Look down here. Okay. And the focus is to use the last column, the GIF, okay, to the power 1 over 2 times the degrees of freedom. This last part, the last part there, that is a critical point that you want to be able to look at. So this section there, you check each variable, and you can see that it is focusing on the independent variables. But when it comes to the dummy variables, if you look at the last three, it uses the category, all of them, the entire group, instead of splitting them. Okay. But whatever it is, the most important thing is that the values are not greater than 10. So you can see that they have all passed the test. Okay, they are all passing the test, none of them. So you should not be worried. So now you can say it in your thesis work that we did a check of multicollinearity, the GIF, the variance inflation factor measured by, then you put this formula down, measured by GVIF to the power 1 bracket 1 over 2 times the degrees of freedom, blah, 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 okay, indicated that none of them was exhibiting high multicollinearity. Now, you can decide to find the VIF and then, check. Now, this one is going to give us the results in 2 decimal place. Okay, so, sorry, did I say 2 decimal place? You are asking it to give you the results and then indicate those that are 10, okay, and flag them, but it doesn't, okay, it doesn't flag them, so it means that none of them is causing a problem. But this one is an interesting one, because this one will ask R to identify which ones are problematic, which ones are problematic, which ones are serious, okay. This command, with the square root of VIF, this command will ask R to determine which ones are serious. And once you run that, it will tell you false, 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 which means that none of them is seriously exhibiting any multicollinearity. You clap for yourself, and then you can now proceed with your work. Put it down and indicate that you did a check and the results were fine. Now, the good thing is that once you have this problem, once you see that there's no problem, you're fine. But what if you did? What if you did have a very serious, I mean, very big, serious multicollinearity? Okay, it can affect the significance of the results. It can affect the significance of the results. How do you deal with situations like that? How do you deal with them? Okay, there is a way that you can deal with them. It means that you may not have to use the OLS again. Sometimes you may have to deal with other means, but we'll come to that. We'll come to that and how to solve them. You may have to use weighted least squares. You may have to log some of the variables. You may have to take squares of some of the variables. You may have to take square roots of some of the variables and all of that, okay, so that you can check it again, okay, if there's a very serious situation. Okay, now there's another way to determine this, and I want to mention that. Okay, dealing with the multicollinear, how do you deal with it if you found it? Now, this command, the library jtools command, is an important command we've already spoken about. You can run that command on this data and show your results, and then you can use this command, sum, okay? So you can use that jtools data and then use sum gmulti VIF true, okay, to tell you which ones are exhibited. This is Fox and Moniti, okay, who introduced the generalized VIF. So this is a generalized VIF. And for numerical data sets, okay, this GVIF is equal to the normal GVIF. Okay. And usually when it is less than 5, okay, it means that the thing is not that critical. But when it is 5 or more, it is considered as critical. Well, we know what others are saying. Okay. So when you read the paper, you can see. But I just want to run this finally for you to see what I mean by multicollinearity. So after running your jtools and everything, you can run this command. And there you go. It's on the far right column. Okay. On the far right column, you have the variance inflation factor there. Now, these variance inflation factor, you can see that they are bigger. They are bigger. So usually when you use this VIF here, it can be slightly deceiving using that. So it is important to use the one that we dealt with before, okay? Because there are some assumptions that will have to be made for this to materialize. But all the same, the good thing is that we've been able to exhibit the multicollinearity situations right there, okay? We've been able to showcase it, we've been able to exhibit it, and all of that. When it is there, the ways of dealing with them is by using other models in addition to the OLS to correct them. And how do you know that it's a big problem when it's there? Well, we've said it. When your coefficients are no longer significant, when most of your coefficients are not significant, then you got to check for multicollinearity. Ideally, you should have checked it before, when most of your coefficients are not significant. Ladies and gentlemen, that brings us to the end of the entire caboodle.